Hello everybody, my name is Deb Mishra. I'm an associate professor in the School of Civil and Environmental Engineering here at Oklahoma State University, and I teach the Introduction to Geotechnical Engineering class, which is 3714, and I'm going to take you through our undergraduate Geotechnical Engineering laboratory that we use for the course. So this is right now we are in front of Endeavor, room number 230. As you can see, this room is called Engineering Material Characterization. This is essentially the Geotech lab. And as you can see, for the safety procedures and stuff, we have the contact person and all the other safety requirements here. So let's go inside the lab. So the first thing you will notice in our lab is how clean this is. That's primarily because we require our students to maintain a very clean workspace, and our PAs, they work very, very hard to make sure the lab is in really good condition for everybody to work in. And these are the stations that we have. And as you can see, if you look up, there are actually power outlets at every station so that the students can not only set up these portable small equipment when they are working, but also their laptops and stuff when they work. Usually the section we run in this class is a maximum of 16 people, and we try to divide that into 4 groups, 4 people, 4 groups each and stuff, and that's how the work happens. So we go throughout the semester about 10 experiments that we do for a typical semester in the Intro to Geotechnical Engineering class, and we go through as the syllabus progresses through chapter by chapter, we go through individual things. The very first thing that we do is actually a visual soil identification, and as you can see, these are 2 examples of 2 bags. We actually have these kind of Ziploc bags that we prepare and we hand out to the students, and they do visual classification. We have some coarse grain materials, we have some fine grain materials, and we have them, for coarse grain make inferences based on gradation. For fine grain they add some water and stuff like that, and they do that. So that's the lab 1. For lab 2, we go into sieve analysis. As you can see, we have a really nice sieve system. Here in this system, it's a dust collection system as well as a soundproof enclosure, and we have 4 sieve shakers here, and all the extra sieves are in the other room. I will show that later, but the 4 groups can work parallelly on these experiments. So they do sieving here and do the data interpretation, plotting and everything. Then we move on and everything. The next one is Atterberg limits, and we have the Casagrande apparatus here. As you can see, these are the electric versions, the automated ones, so that the students are not rotating at the specified rate. They don't have to watch that. We do have manual ones as well that are being introduced in the lecture to tell them that how these tests are run. And we have right here you can see the plasticity, plastic limit rolling plate and everything, and all the extras. We have a lot of storage in this lab. We actually store a lot of extras in here. We have a lot of spare parts so that the students, if by any chance there is an accident, the students' learning does not get hampered. We do have Atterberg limits, all the other stuff that we do, basic soil classification. We can do basic ASTM classification for everything. One of the things is the specific gravity tanks. We can actually do specific gravity of aggregates here, and we have what else am I missing? We have the compaction, of course. We do a standard Proctor, modified Proctor. All of the molds and hammers, they're all stored here, and they can actually work on the compaction. They have the extractors, mold extractors to extract the sample after compaction. Here is the oven that they use. We have the oven mittens right here so that they follow extreme safety protocols and stuff so that they are safe. Then we also have the field density measurement demos. Here we of course cannot keep the nuclear density gauge here, but we have the sand cone set up, we have the rubber balloon set up so that the students get exposure to that. Sometimes they are just given as a demo, sometimes they actually get to go to the field and do this. Then we have the permeameters for permeability. People do that hands-on. We have the triaxial setups. As you can see, We have this lab, most of the big equipment, they're actually set up through Humboldt. We have 3 independent panels of the triaxial setups with all the moisture control, pore pressure measurement, abilities and everything. So 3 of them can work in parallel, and also we have 3 direct shear setups through Humboldt as well. And these are all connected through the computer. They can all be essentially daisy chained and operated through 1 computer or 2 computers, or however you want to do. We have 8 or so consolidometers that they can actually do consolidation testing. In this version right now that I am showing, this is actually a manual data collection, but we also have data loggers that will enable them to collect the data. I don't think I missed everything. All the equipment, there is actually a storage area over here where we actually keep a lot of our storage, some of the spare ones that we also have, so that the students' learning is not hampered. As you can see, all the sieves are stacked here, and our lab is pretty well equipped, and they get exposure to all sorts of testing that they need to know to be familiarized with the concept of geotechnical engineering. So this was just an introduction to our lab, and if there is any questions, please feel free to visit our website and contact any of us at the department, and we'll be happy to help you out. Thank you. Go Box.